Awesome. So it's saturated because we have more than necessary and we didn't heat it up and then cool it down. We just added it to that temperature degree. Okay. Next up. At what temperature do lead nitrate and potassium nitrate have the same solubility? At what temperature? All right, good. 49 degrees Celsius. So you found where lead nitrate and potassium nitrate intersected. Look down at the temperature, saw it's closer to 50, but just under, and that was 49. Okay. What temperature is necessary to dissolve 15 grams of cesium sulfate in 100 milliliters of water? Okay, so 4 degrees Celsius. So we're looking at the minimum necessary to dissolve 15 grams. So yeah, 15 grams. So we go to 15 grams, grams is on this axis, 15 grams, find cesium sulfate and see that it is just under halfway to 10, which would put it between 3 and 5. And we see a 4 degrees here. So that's the one that makes sense. Everything else would be too big. What is the solubility of lead nitrate at 60 degrees Celsius? And yes, I see my typo. No, I haven't fixed it. Okay, so we go to lead nitrate. We go to 60 degrees Celsius, follow it up all the way to lead nitrate, see that it's halfway between 90 and 100, and that's why we picked 95. Awesome. And it was 95 grams, not 95 degrees, because grams is on the left, degrees on the bottom. I have dissolved 50 grams of potassium chloride, then lowered the temperature to 40 degrees so all of it stays dissolved. Yes, it is super saturated. So tell me the difference between this one and the last one, Faisal. Why was the last one saturated when it was above the line and this one's super saturated when it's above the line?
The last one was because there was 10 that was still left out, and here it lowered the temperature to 40 and then all of it stayed. So nothing was left out.
Yes, and it was left out before because we just added it at that temperature without heating it and then cooling it. We must heat it and then cool it to get a supersaturated solution because it is unstable. Perfect. Love that answer. You did such a good job. And that was not an easy question. Look at you go. All right. Which salt is the least soluble at 10 degrees Celsius? At 10 degrees Celsius, who is the least soluble? Yes. So we go to 10 degrees and we find the line on the bottom, and that was potassium chloride. So that is why that is the least soluble. The least amount of grams of solute dissolves at 10 degrees. Awesome. You guys are doing great. Look at you go. What is the solubility of potassium chromate at 90 degrees Celsius? Yes. Look at you guys. You're doing so great. You found 90 degrees, you went to potassium chromate, saw that it was right on that cross section at 70 grams, and it means 70 grams will dissolve in 100 grams of water. So Darshan, the only time that supersaturated solutions have stuff fall out is if we add more solute to it. So supersaturated solutions form crystals when disturbed by something of a similar shape. So like crystals have sharp edges, right? You're literally physically disturbing the molecular structure and they're like, I'm unstable, I don't like this. And they latch on to what is stable, which is that crystal. So unless it's disturbed, it won't. That's why like sweet tea, you might see crystallization on the top of the milk jug, but not inside the actual liquid itself. You don't get chunks, right? So that's the idea, is that supersaturated solutions will form crystals because they're unstable when they are disturbed by the same substance they are unstable with, because they have to be able to bond, right? That's the process called nucleation. Nucleation. Okay. I love your questions though, Bubba. They're always so good. What relationship exists between solubility and temperature for most of the solutes on the graph? Yes, as temperature increases, solubility increases for all of them but cesium, and cesium sulfate is a special case. So we are increasing as we go right for most solutes, very few exceptions. Okay. What is the solubility of potassium chlorite at 50 degrees Celsius? This is the last question, guys. Yes, 18 grams. So we go to 50 degrees. We find potassium chlorite, which is here. And we see it's just under 20, but it's not at half. It's above half, but under 20. That's why it was 18 grams. Perfect. All right, let's see who got it. Milan, you were close. You did a great job. Then Izzy, and who won? Who was it? Yay, round of applause for Maddie. Woo, yay, Maddie. Okay. Corey and Jessica, honorable mentions. Awesome. Are there any questions about solubility before we move on to math? Because math is everyone's favorite thing. Okay, before we start, I want everyone to physically check. Do you have your reference packet? Yes, Darshan, you can say after. All right, do you have a reference packet? If the answer is yes, you are good. If the answer is no, go get it. We are actually using a new page that we haven't used in a while. So most of our work today is going to be right here under solutions. Do you see how that's the name of our unit? We are going to be dealing with this for unit 7. Unit 8 is where we're going to use all this stuff. Okay. You also will need this. Okay. The metric conversions. That was real bad, but I tried. You will need this. So these are the two things that we really, really, really need today. Okay. You may also use something out of the constants and conversions, but these are the main two things that we have to have. Okay. We're talking about solutions. Okay. So make sure you have your reference packet. Make sure you have your notes. So unless it's a stoichiometry problem, like at the end here, we have, oh, what did I do? I went way too fast. Oh my goodness. Hold on. I've mega failed there. There are some problems that have chemical reactions, and those are going to follow the normal stoichiometry steps. But before that, we're going to do the questions that have to do just with molarity. So like most things in math, coming from the math certified half of me, like I used to teach math and science, now it's just science. the math thing that's the most important is when you have a formula sheet, write down all of your variables and givens in terms of the actual name of that category of variable. So what I mean is, like, if I'm given grams, I don't just write 21.83 grams. I would write lowercase m to indicate mass is grams, because I can find that on my formula sheet. If I'm given milliliters or liters, I know that's volume. I'm going to label that with a V. If I see density, right, I'm going to label that as density or rho or whatever it is. So make sure that when you're given something, you label it as you're given. And that is my number one tip for this whole unit. Label, label, label. Labeling lets you match to formulas so you can plug them into stoichiometry or whatever else you need. That if you can master that, you will be just fine. But you have done all of these mathematical operations before. These are multiplication, division. There's not like logarithms or anything weird. It's all algebra, like more, I don't want to say simple, but basic operator, multiply, divide, add, subtract. It's not super complex yet. So make sure you get this down really well, because that will help you next unit. Okay. Are there any questions about any of that before I move forward? And I'm taking the time to say it, so it means that it's really important because it's come up multiple times in other classes. Okay. So this question, it says, Miss Jones, let me pull up my wheel. Miss Jones mixed 21.83 grams of calcium chloride dihydrate into 500.0 milliliters of solution. What is the molarity of the solution? So my hint to you was, except for the molar mass, do not round to the very end. Do not round in the middle. Okay. So, Rafid, is that the correct? Am I in the correct? No, that's not, I'm not in the correct class period. Hold on. Pause. Open. All right, now go. Celine, what do I do first?
Pick apart the important information in the question.
Awesome. Help me do that.
So there's 21.83 grams of calcium chloride dihydrate.
Okay.
And
What
then
variable is that? What type of variable?
I don't understand what you're asking.
Yes, grams means it's mass, volume, molarity.
Okay. Mass.
It is mass, right? Lowercase m. Lowercase m. Okay. Awesome. What else do we have?
500 milliliters of solution.
500 milliliters of solution. So what is that? Mass, volume, molarity?
Volume.
Yes. 500 volume. Okay. What else do we need to know?
What it's asking for. So it wants the molarity.
What letter do we use for molarity?
Uppercase M?
Yes, it is an uppercase M. Like I said, it's very important that you guys know. How else do we write molarity? What is that unit? What should I think every time I see that?
I'm not sure.
Okay, let's go to the formula. When I see capital M, I should think what?
Moles over liter?
Yes, that is equal to moles per liter. So this is my formula, right? Molarity equals moles over liters. The way we write moles in math is N. The way we write liters is volume. Okay. Scale of 1 to 10. How are we doing so far? All right. Those look like good numbers. Charles, you're up. What do I do now?
Would you have to convert the grams of calcium chloride to moles?
Yes, we need to go from grams to moles. How did you know?
Because the mole or the molarity solution or equation is moles of solute over liter of solution.
Yeah, so we have the 21.83 grams of calcium chloride dihydrate. I'll pick on someone else for that. Carter, how do I build calcium chloride dihydrate? What does that look like?
So obviously you have to start with calcium.
Mm-hmm.
And then you have to get the 2 chloride.
Yes, and we do that because calcium is 2 plus and chloride is 1 minus. So we need 2 chlorides so that we can add it to 0, right? Except for all the weird markings it makes. Awesome. What else is on this formula?
Our dihydrate, which would be 2H2O.
Yes, the word hydrate is just like when if I told you to hydrate in Texas, I would be telling you to drink water. So it's water molecules, and the di means there's 2 of them. Perfect. So I need to convert this to moles. So next up, Izzy, how do I do that? How do I convert that to
Is this where you would use the atomic mass?
Yes, it is. So we'd use this like a formula. So you'd have 1 calcium plus 2 chlorides plus 2 times 2 is 4 hydrogens plus 2 oxygens. And that's going to be a molar mass. So I want everybody to plug that in your calculator because calculators are stupid. Calculators are very stupid. And I want to say again, calculators are very stupid. So I want you guys to all practice and then put in the chat what you think the molar mass is that we should be plugging in so I can verify you know how to calculate molar mass. I want to see that from everybody. Dia, you're good? Faisal, you're good? Still waiting. Everybody should be doing this. Every human in the room. The virtual room. You're good. Darshan, you're good. Maheen, good. Kira, good. Bob, you're off a little bit. Try again. I think you just forgot one of the elements. It looks like you just didn't type it. Same thing for you, Shanmati. Megana and Milan, you're good. Sonali, you're good. All right, so if you guys do this right, you should have gotten 147.0136 grams per mole. Awesome. So Lucas, how does this number help me? How do I convert this to moles?
You'll take that number and divide. You put that on the bottom of the, yeah, right there.
Yep, so that's the grams, and then the moles goes on top. And that's for the CaCl2, 2H2O, CaCl2.2H2O. Awesome, so that's gonna give me moles, okay? So when I do that, and I plug that in my calculator, how many moles does it give me? Corey, how many moles does that give me? 147.0136 into 21.83.
1 second. I'm entering it in the calculator.
Okay, that's fine. Trying to make sure. It annoys me so much that it connects my fours. I don't know what I'm doing with my hand to make that happen, but I'm not a fan. Not a fan. Okay. Plugging in my little tablet so it doesn't die. Maybe that's why it's being funky. Probably not, but one can hope.
So should I put it in scientific notation or
No,
just
leave
the
it
answer it gives? Okay.
natural for now.
It's 0.1484 moles.
Okay, so 0.1484. Now remember what it says, don't round to the very end, so we are good. So we're ending up with, this is our moles. So that's one part of our equation. We've got the moles, check. We've got the N, that's good. What else do we need? What else do we need? We have the moles. Esty, what do we need now? What's the other part of our equation?
We need to get the other the liters. Sorry, just
Yeah, so we have 500 milliliters. So if we're going to convert that, remember when I told you guys you will need your formula sheet? If you don't have this memorized, you can look right down here and see that 10 to the third milliliters is equal to 1 liter, right? So that's this idea. 10 to the third liters is equal, or milliliters is equal to 1 liter. So how do we use this to convert our volume?
you have to move the dot over 3 times because it has it's 10 to the third power.
Yes, and I already can hear that in your brain, you knew that goes on the bottom because you said move to the left, which is the same as dividing. So you did that fabulous. And I love that you did something in your head so well, you didn't even realize you did it in your head. That was awesome. So we move it to the decimal 3 times and we get 0.500 because we have to keep, or 4, we have to keep all of our 4 sig figs. So that's 1, 2, 3, 4 sig figs. And that's going to be in liters. Awesome. So now we have liters. Check. So what is our last step? Akshar, what's our last step?
You have to just sig figs.
Well,
and
not just sig figs. We have our 2 parts of our formula. We got moles and we got liters. What do we got to do with it now?
just divide it.
Yeah, so we had to convert to get moles. So that was the 0.1484 moles. And then we had to get liters, which was the 0.5000 liters. And when we do that, we should get our formula for molarity. So what did you get out of the calculator, Bob? I don't know if your mic is working, but we'll see. Oh, what did you get out of the calculator?
Can you hear me now?
I can hear you.
Oh, finally.
Okay.
Don't know what I got out of the calculator because but if I turn in the batteries. All right. Y equals oh no, that I put in 1 less 0 for the 500.
The zeros aren't going to affect the value out of the calculator unless you forgot the 0. It needs, as long as it's 0.5, you're good.
Yeah, 2968 or 0.2968.
68, and then what else? You got to keep going.
All right, significant figure.
Because you need
Oh,
one.
right. The units, right?
Yep. Well, in your calculator, was this a 9?
No.
What was the next digit?
It didn't give me a next digit.
It didn't. Weird. Okay.
It just gave me 4 digits.
That is okay. Oh, I know, because when I did it, I typed in something. You're right. You're right. Okay, sorry, my brain's going back to a different class period. So that's 0.96, and yes, I need the units and what it's for. So what unit would be here?
Moles.
So we have moles per liter, which is the same as molarity or capital M. We say this molar, just like your molars on your jaw and your teeth, right? 2.968 molar, CaCl2.2H2O. So that's what it would be. If you guys typed in the calculator differently, you may have gotten 0.2970, but that's only if you typed it in slightly differently. So that would be okay within the margin of error. How do we feel so far, guys? You did a good job, Bob. Thank you. Oh, there's something in my eye. I'm so sorry. It totally distracted my brain. But how are we doing? Scale 1 to 10. Okay, looking good. Next problem. Magana, Mr. Haredum, or the legend, uses 0.825 moles of sodium bicarbonate to make a 0.300 molar solution. How many milliliters of solution were made? Darshan, 1 times 10 to the 3 is the same as 10 to the 3 because 1 times anything is itself. So I left it off, so it's less to type in the calculator. That was a good question. Magana, what do I do first here? What is in my eye? I'm so sorry, guys.
You have to write down the stuff that you know and what you're trying to find.
Awesome. So can you do that for me?
You have 0.825 moles of sodium bicarbonate.
Okay, moles. What letter is that? What do we say moles was? Like we know volume is capital V. What is moles? What's the letter we use for moles? Yeah, N, because it's number of moles, because it's a count, right? N, okay. What else do we know?
0.300 M solution.
M, this capital M is pronounced molar, just like your teeth, molar. So that capital M is the same as its unit, 0.300 molar solution. Awesome. And what are we looking for?
Milliliters of solution.
So what is milliliters?
Volume.
Yeah, so that's volume equals question mark milliliters. That's important. Okay. All righty. So reminder, next person. Thank you, Magana. You did great. Samir, what should we think of every time we see capital M?
Probably moles.
Yeah, capital M, it has something to do with moles. What moles is on the top? What's on the bottom?
Oh, what's on the bottom? That's gonna be your liters.
Yes. So whenever you see the capital M, you should think moles per liter, which is why I said this was important, because when we use this, we're getting liters and we'll have to convert it after. Okay.
Okay.
All right. So next up, Sonali. Sonali, here's the formula sheet. Which formula do we need? We have N, M, and V that we're trying to use. So which one of these formulas are we using?
M.
Yeah, this one. Yeah, because this is the V. So these are the 3 variables. So I said, guys, if you don't know where to start, write your variables and match them to your formula. Okay, so we're using this formula again. So we're using that molarity is equal to number of moles over volume. Okay, so good job, Sonali. Next up, Trisha, what do I do now? I have my formula I'm using, right? Sorry, I need to, that looks really weird. What do I do now that I have my formula? Are you there, Trisha?
Do you plug in the numbers?
You can plug in the numbers, right? I always recommend we rearrange first, but if you want to plug in numbers, fine. Because sometimes once we plug in numbers later on in chemistry, if we plug in the numbers first, it gets really confusing. But if we rearrange, it makes it easier. So the habit I want you guys to build is to rearrange first. So what will we rearrange this for, Trisha? Not that you're wrong. I'm just trying to teach you guys a habit that'll help you later.
It's you have to find what V equals.
How do I isolate V?
It's V equals, I think is it M times N?
So the way we would do this is division, right? So to get rid of division, we have to do the opposite. What is the opposite?
Multiplication.
Multiply V by both sides, and that would cancel the V. But now V isn't by itself. So what do I need to do now? These are multiplied. So what's the opposite?
Divide.
Divide by capital M, divide by capital M. So I would cancel those. So I end up with V is equal to N over capital M. They switch places. So this is what I'm using when I plug in. Does that make sense, everyone? So when I plug it in, I end up with the N over the M. So help me figure out what I need to do. Kiera, talk me through what I do now.
So you would put N on the top and M on the bottom. So that's 0.825 moles on top. And then 0.300 molars on the bottom.
Yep. And so that gives me what for my answer for my volume? When I plug that in. Let me ask someone else. You did a great job. All right, Stina, tell me what you get out of the calculator.
I'm typing it in. I got 2.75.
Yes, you get 2.75. What unit is that?
It would be milliliters.
So it's not milliliters yet, because what is molarity? That capital M means moles per what?
Oh, moles per liter.
Moles per liter. So we canceled out the moles. We're left with the liters, right? Is that what we were asking for?
No.
So we got to use that same conversion. 10 to the 3 milliliters is equal to 1 liter. So how do I plug that in? What goes on the top and bottom?
Wouldn't the liters go on the bottom because?
Yes. Why is it on the bottom?
Because you have to have the same unit.
Yeah, you cancel those, right? You want to be left with milliliters. So that gives me 2750 milliliters. Now, is this the correct number of sig figs?
It has to be 3. So
Is it 3?
No.
Are you sure?
Oh wait, yes it is.
Why?
Because the 0 doesn't count when you're counting.
When would it count? When would this after 0 count? What would have to be there?
There was a decimal point after.
Yeah, there's no decimal though, so it's just these 3. This is my answer with the sodium bicarbonate. Okay, you didn't even have to figure out what sodium bicarbonate was for this one. How cool is that? Scale of 1 to 10, how we doing? I know I'm going slow, but it's because I want you guys to see something in great detail. Okay. Mrs. Fowler dilutes 12.6 milliliters of a 6.00 molar solution of hydrochloric acid to 2.50 liters. What is the molarity of the new solution? Audrey, start me off. What do I do?
Hi. You have to find the molar mass.
So before we figure out anything and do any math, what do we have to identify?
Oh, what you're looking for?
Yeah, we want to identify what we're looking for in all of our variables. So we know if we're using a formula, if we're doing stoichiometry, we got to figure that out, right? So can we identify? Tell me what's important.
We have milliliters.
Okay, we have this number. Okay. What else do we have?
And then we have 2.50 liters.
Okay, so we have another volume. Let me write that down here. Okay, what else?
And then the 6, is that meters or like mass?
The capital M stands for molar.
Okay.
Which is just like you say, just like your T. So you'd say this 6.00 molar. And we know that molar is equal to moles per liter. Okay. So 6.00 molar is in here. Okay. What are we looking for?
The molarity of the new solution.
Okay. So here's my question. What variables, like what things will we look for in a formula? Like we know that volume is V, right? But there's 2 volumes here. So how could I write those down in a way that would make me understand what is what?
You could use different variables.
You could use different variables, but let me ask you this. When you guys were doing slope in algebra, and it's like the change in Y over the change in X, what did that mean? It was y something minus y something over x something minus x something.
It was like y2 minus y1 over x2 minus x1.
So we're gonna do the same thing here. So we have to figure out what came first and what came second. Okay, so which variables, so this is one solution. This is another solution. Which one came first?
It's the 12.6 milliliters over the 2.5 liters.
Yeah, so this is volume 1 and this is molarity 1. How did you figure that out?
Because she's diluting it into the.
Yes, it says I need to go to 2.5 liters. So this to word is a transition word, meaning this is what we're going to, as in this is last or second. Perfect. So that's going to be V2. So what we're looking for is M2. So this is why I have you guys write variables. If we aren't sure what we're supposed to do next, okay, take a look at these formulas. These are the two formulas we're choosing between. How do I choose which one I use? Hold on, sorry, I forgot to spin the wheel. That was me. My brain is slow. Evangelina, how do I decide which one I use? Are you here, Evangelina? No, I'm talking to a ghost. Ugh. All right, hold on. Dia, I know you're here. Dia, how do I know which formula to use?
We would use the V1 times M1 is equal to V2 times M2.
Yes, because that is the variables we have here. All of our variables match. Now, just disclosure, I really struggle when I write this because my entire chemistry career, I've always seen it M1 V1 equals M2 V2, but 1 times 2 is the same as 2 times 1, so the order doesn't matter. But like if I start writing it in a different order out of habit, please forgive me and know that like I don't know why they didn't put it in alphabetical order, but it's just mean. So I've never seen it written without alphabetical order, but that's okay. My OCD is going to have to chill. I'll write it the way it's on the formula most of the time. I'll mess it up sometimes and you guys can laugh at me. All right, not that it's messed up because commutative property is a thing, but anyway. So we have V1 M1 is equal to V2 M2. Okay, so this is what we're plugging into our formula. Our M2 is what we're looking for, so that's not going to have a number. So if we have what we're looking for, it's best to isolate it first. So you tell me how to isolate it. How do I isolate it? Are you there, you? I see you're unmuted, but I can't hear you for some reason. I saw your green light up and all of that. Is that really quiet for everyone else? I can barely hear you, doll. There we go. How do I isolate this variable?
You can divide by V2.
Yes, I divide by V2. That means this V2 cancels. So I get V1 M1 over that V2 is equal to the M2 I'm looking for. Okay, so I can just plug all of that in. So my V1 I already have identified is up here. It's 12.6 milliliters. What is going to be my problem? Does anyone see it before I call anybody? What's my problem? What do you notice?
One volume is in milliliters and the other one is in liters.
Yeah, this is the problem. Good catch. Milliliters and liters. It does not matter which one you convert as long as they are the same. So what would you like to convert to since you caught it?
Milliliters.
Okay, so we're going to convert this one to milliliters. So we know we have 2.50 liters. We're going to use that same conversion factor that we looked up before. We're going to use that a lot. So my 1 liter goes on the bottom, my 10 to the 3 milliliters goes on the top. So that's going to end up being 2,500 milliliters. So that is what I'm going to plug in here. 2,500 milliliters times the, oh, I'm sorry. Wait. No one called me out. What is wrong with you people? Ugh, just kidding. Nothing's wrong with you. We're doing M1, V1. So we converted to milliliters. So we can do these as these are. So we'll do the 12.6 milliliters times the 6.00 molar is divided by that second volume, which we converted to 2,500 milliliters. So we could cancel these milliliters and now we're left with molar, which is what we wanted. So for that M2, when I plug it in, what do I get out of the calculator? Renee, what do I get out of the calculator?
Sorry, 1 second. 0.03024.
Yes. So you get 0.03024. What unit is that in?
Molar.
Yeah, the capital M. So now I need to make sure I have the right number of sig figs. This has 3 sig figs. This has 3 sig figs. This has 3 sig figs. How do I get this guy to 3 sig figs?
You would do 0.030.
So if I did that, where are you counting from? Where do we start counting our significant figures from?
The 3, so it'd be 0.0302.
Yes, so we do our 3 sig figs from the first non-zero number. This would be our answer, and that's the molar of the hydrochloric acid. There we go. All right, scale of 1 to 10, how we doing? I know I'm going slower, but it's because you guys have a test and I want to make sure you have this. And there's something in my eye is driving me crazy. I'm so sorry. I cannot stop myself with my face. Okay, and my Visine is at home. Sad day. Okay. All righty then. Mr. McDermott needs a 0.450 molar solution of sodium chloride. How many milliliters of distilled water must be added to 15.0 milliliters of a 2.25 molar solution of sodium chloride? So Victoria, start us off. Are you there, Victoria? I see you're in the room. I can't hear you though. Are you there, love?
Wait,
There you go. Yep, I can hear you now. So how do you start me off?
So we need to find what we're given and what we need to find. So we are given 0.450 molar solution.
Yes.
Sodium chloride.
Yeah, and what else
And then we're given 15.0 milliliter.
We're given 15.0 milliliters, so that's all right. And then what else?
We're given 2.25 molar solution sodium chloride.
So what variables go with which things?
Is it like V1, M1?
Yeah, this is V1 and this is M. How did you know?
Because they give us molar and milliliters.
Yeah, well, also, you know, it's the first one because it says this is what he needs to make. So this is what we end up with. So that's the second one.
And we need to find the second volume.
Well, we need to find the second volume, but here's the trick question. Is this what the question is asking for?
Wait, no.
Well, we need to find it, right? But what are you asking for?
Milliliters of distilled water.
Yeah, milliliters that must be added. That's really important. Why does it say must be added?
What sucks that I don't got no.
Are we starting at 0?
Yeah.
No.
No. So when I find this, It's gonna be the total volume. But we need to subtract the total volume from the starting volume, so that way we can see what's left over. And that will be my question. This is what I'm looking for in the problem, and that needs to be in milliliters. So we have 15. What are we going to end at, and how much did we add to get there is what the question is. So basically it's saying you've saved up $15. How much money do you need to buy a new pair of jeans, and how much more money do you need to get there? That's kind of what the question is asking in real people talk, not chemistry talk. Okay. So next up, Gus, what law are we using? What equation? What equation do we need here? Are you there, Ganesh? I know you go by Gus sometimes and Doug sometimes. Someone text him, tell him that I'm talking to him. Are you there, Ganesh?
I'm texting him right now.
Okay, that's funny. It's like, dude.
He's in the bathroom right now.
Okay, never mind. I'll own someone else then. I will come back to
I'm
him.
not. My desk just fell apart and I'm trying to fix it because it's falling on me.
That's not a good thing. Let's not have desks fall apart. You know, that's important. I'll come back to you. Let me know when you're good in the chat, okay, Ganesh? Wajiha, what formula am I using here?
Are you using the second one?
Yeah, we're using this one again. So we have the law that we're using is the M1V1 is equal to the, see, I already wrote it backwards. I just saw that I did that. I just said I was going to do that, and then I just did it. Why did I don't even care. You know what? M2V2, okay? So this is the law that we're using off of our formula sheet, okay? So we need volume 2. So let's isolate volume 2 first. So Kai, can you isolate this for me?
Yeah, so you would need to divide the M1 and V1 by the M2.
Yeah, so we cancel this out. So I end up with V2 is going to equal M1 times V1 over M2. So let me plug that in, okay? So I get equals, so my M1 and my V1 were written, right? And notice that it's already in milliliters and it's asking for milliliters. So I'm not gonna convert it because it's in the unit I'm looking for. So my M1 is 2.25 molar. My V1 is 15.0 milliliters. And then my M2 that I am looking for that Mr. McDermott needs is 0.450 molar, okay? When I plug that into my formula, I should get, if I did everything correctly, I should get 75.0 milliliters. So everyone put that in the calculator and make sure you get 75 right now, just to make sure you have your calculator skills, because calculators are what? What are calculators?
Dumb.
They're dumb. They're so dumb. They're the dumbest. Okay. They are dumber than anything you've ever met. So 75.0 milliliters is our total volume. All right. So Jessica, am I done?
No, you're not.
What do I gotta do now?
You have to subtract it from the 15 ml.
Yeah, I've got to subtract. So I had 15. I need 75. So that means I need to add 60.0 milliliters of H2O. That is my answer. Scale of 1 to 10. Okay. All right. We are going to move into the land of stoichiometry. So Yes, Adia, it'll be worded exactly like that. How much water must be added? How much additional water is needed? But you will always have, like, if you say how much water must be added, it's always what we have and then going to what we get to, okay? If you have to change it between liters and milliliters, so say it asked for it in liters, you would do that same 6.0 milliliters, and I would do the 10 to the third milliliters in 1 liter to convert it to be 0.060 liters. Okay, so I would just do that thing. So you would just use that known factor, the 10 to the third and the 1, to be able to do that. Okay. All right, any other questions? All right, Mr. Willis reacts 16.5 milliliters of a 1.20 molar solution of potassium phosphate with excess copper 2 chloride solution. What is the theoretical mass of the precipitate produced? Okay, so what this is asking for exactly, do we understand? Let's see, what is this actually asking me for? Because again, we see a chemical reaction, so we know it's stoichiometry. Sia, what is it asking us for?
Is it asking us for the mass of the products?
The mass of the precipitate produced, right? So mass tells me it's what unit?
Grams.
And then what is precipitate?
The solid that's formed after the reaction.
Good. So it's asking us for that. It's asking us for grams of Cu3PO4 produced. Does that make sense to everyone? So we're looking for grams. If we don't have grams of copper phosphate at the end, we didn't do it right. Okay, Sangeet, we already have the chemical reaction. It is already balanced. So what is step 1 of stoichiometry?
Convert to moles.
Yes, we need to convert moles, okay? So we need to use the part of the formula that can get us to moles, okay? So if of our knowns, we have 16.5 milliliters, right? 16.5 milliliters or 1.20 molar, okay, of potassium phosphate. Which one of those has the greatest potential to get us to moles?
So molar equals moles over liters.
Yeah.
So you would use the molar.
Yes, I could use this formula to find the moles. So here's the tip I give you. When you're doing stoichiometry, when you're picking the unknown, start with the known whose units are alone. And it rhymes and it's stupid on purpose. Start with the known whose units are alone. So when you're looking at milliliters versus moles per liter, which unit is alone? Jonavi. Which unit is alone? Are you there, Jonavi? This is my question of the day. Jonavi. Okay, I'll come back. I already called on you. Why did you not take you off? Jimin, help me out. That's okay, Jonavi. Jimin, are you there?
Yes.
Okay, which unit is alone? Is it moles per liter or is it milliliter?
Milliliter.
Milliliters alone. So that's what I'm going to start my railroad track with. I'm going to start with 16.5 milliliters. Okay. So this is going to be very long. So you guys remember when I told you guys that the hardest part about stoichiometry, the higher you go, is that it may take more than one step to get to moles, or it may take more than one step to convert. This is where that starts. So to convert to moles, we need to use this known relationship, right? So if I have milliliters, but my molarity is in liters, what do I need to do first? Shanmathi, what do I need to do first?
You need to convert the milliliters to liters.
Yes, so I'm going to use the same relationship we've talked about a bunch of times today, so I'm just going to write it. The 10 to the third milliliters over 1 liter, because these milliliters need to cancel. And now I'm in liters. Awesome. So now that I have liters, how do I convert to moles? Because that's step 1, right? We're trying to convert to moles. Ray, what do I do first? Or what do I do next? Ray, are you here? There you go.
Would you convert it to grams and then convert it to moles?
You do not have to convert to grams. What was I given? What does this mean?
You multiply the m.
Yeah, so 1.20 molar is equal to 1.20 moles per liter. Can I use this to help me? How would I plug this into my formula up here?
Would you would multiply it and wait, hold up. Would you would plug it up top, right?
Yeah, 1.20 moles would be on the top. 1 liter would be on the bottom because we're trying to cancel liters, right? This is the same as saying 1.20 moles is equal to 1 liter, right? So this is how those units break out. So now we have moles. So all we did was our step 1 of convert to moles just took more than 1 step, but that's still all we were doing. We were doing whatever we had to with what we were given to get to moles. Does everybody understand that? Yes, no, maybe so, I don't know. It's the same as last unit. Okay. Step 2. What was step 2 of stoichiometry? Eden, what's step 2? We converted to moles. Now what do we do?
Molar mass.
Not molar mass, because we already have it in moles. That was the whole goal, right?
Oh, and is it mole to mole?
Yes. Now, the reason you're confused is because when he told me this, right, I was going to let it happen just to show you guys why it's important again. What am I missing from here that I normally would write?
Would it be potassium phosphate?
Yes, which is this one, right? So I would have written K3PO4. Why is that important for step 2? What are we doing on step 2?
The mole ratio?
Yep, so we're comparing this to what we're going to, and we're going to copper to phosphate, right? So what do I put on the top and bottom? What would I write here?
So on the top you would do copper 2 phosphate and 1 mole of that. And then on the bottom you would do would it still be 1.0 of
How many moles are there?
Oh, 2.
Awesome. So what that did for us is now moles of K3PO4 is canceled, just like it was before, and we're left with moles of Cu3PO4 too. So the third step after that is to convert to desired. So Ganesh, is your desk still trying to kill you, or are you okay?
I'm all right.
Awesome. I'm so glad you lived. That's fantastic news. Okay.
I'm very happy too.
I know, right? I'm pretty sure you're happier than I am, but that's okay. So, because it's your body. I just realized how that sounded. That did not mean to be mean. Anyway, we're just going to move on. So, step 3. What do I do now? So, I converted to moles using 2 steps. Then I compared moles. And what do I have to do on my third step?
We got to convert that bad boy back into grams.
Yes, we do. So what goes on the bottom?
1 mole of the Cu3PO stuff.
Yeah, it's a lot, right? Copper phosphate's much easier to say. Copper 2, right? Copper 2 phosphate. And then we would need to do grams of Cu3PO42. So you guys need to calculate the molar mass of this bad boy, okay? When you do all of that, when you plug in the molar mass, you should get a number. So what I want you guys to do is I want you to calculate the molar mass first. So calculate the molar mass and then drop it in the chat when you've got it for CO3PO42. CO3PO42. So that's going to be 3 times Cu plus 2 times P plus 8 times O, because this 2 applies to both of these. And that should be a number. Drop it in the chat when you've got it. When I get the first right answer, I will confirm or deny. Yes, 380.578. If you plug this in your calculator, again, when we're plugging things in the calculator, right? I'm going to erase this so that way I can do it. When you plug it in the calculator, you would do it where you pretend each line is parentheses. So I would write open 16.5 close, open 1 over 1,000 close, or 10 to the third. My brain just did that automatically. Open 1.20 over 1 close, open 1 over 2 close, open 380.578 over 1 close. And when you do that, you should get 3.7678 yada yada yada, which then we round to 3.77 grams of the Cu3PO42. There we go. So make sure you can get that in the calculator, but this is as hard as it gets. The only difference between the stoichiometry we've been practicing every single class and this one is that this part right here, converting to moles, took more than one step, but that was all we were doing. We used volume. We made our volume unit what we needed to do the molarity to get to moles. That is literally the only difference. Everything else is exactly the same. Okay. Scale of 1 to 10 in the chat, how we feel. Okay. So here's what I'll say. QC 4.5 is due tonight. It is due tonight. Okay. I have one more, actually I have 2 more versions of this problem that you can do if you would like to stay. But if you do not want to stay, you are free to go at this point if you understand this. Okay. I have this question that if you get it right, you end up getting 1.00 as the answer. So if you want to try to work this problem to see if you get 1.00, you are free to do so. I just want to make sure that you guys have the time to go if you want to. So have a great day. Remember, test is next class. 7.5 is due tonight. Okay. All right. Adios, friends. If you have a question, you can stay after.
Thank you.
Okay. You guys have a question?
I'm just here to see if I can get this correct.
Okay, that's fine. I can mute myself.
Same here.